Welcome. Today we will discuss the polynomials and factorization of ninth class. So first we will discuss one example, that is example 1. P of x is equal to x plus 2 and we have to find out P of 1 comma P of 2 comma P of minus 2 P of minus 3 dash dash dash, like that we can find. So for this what will we do? So what does it mean P of x is equal to x plus 2? Means in the place of x we have to substitute here to find the value of P of 1. In the place of x write 1. So what will happen? Just observe. So P of 1 is equal to, in the place of x write this 1. So 1 plus 2, that is equal to 3. So by substituting 1 in the place of x we got the value 3. That means this 1 is not the 0 of this polynomial. Yes, that means we are finding the value by substituting x is equal to 1 for this polynomial x. P of x is equal to x plus 2. Next take P of x plus 2, sorry, P of 2. So in the place of x write 2, that 2 plus 2, that is equal to 4. That's it. So this 2 is also not the 0. And take one more, that is P of minus 2. So in the place of x write minus 2 plus 2, 0. Yes, here by observing we can say that. So x is equal, in the place of x write minus, by writing minus 2 we got 0, no? That's why x is equal to minus 2 is the 0 of this polynomial. Yes, so we have to find out next. Again we should find the value of P of minus 3. So P of minus 3 is equal to minus 3. In the place of x I am substituting this minus 3 plus 2, that is equal to minus 1. Suppose if you are asked to find P of minus 4, P of minus 5, P of minus 6, then by substituting the values we get the values. But the 0 of the polynomial is only 1 exists. Why? Because the power of, in this polynomial x plus 2, I will write the polynomial is P of x is equal to x plus 2. So this is the polynomial. In this polynomial, first you write the degree. What is the degree? So degree is equal to, here x has the power 1. So that degree is 1 because its degree is constant, its degree is 0. So if the degree is 1, we get only 1 0 of the polynomial. So x is equal to minus 2 is the answer. That's it. No need to find the remaining when you are asked to find the 0 of the polynomial. Right. And the remaining P of remaining values we can find. Next, take another one. That is example 4. Take the example 4. So what is the question? The question is verify whether 2 and 1 are the zeros of polynomial x square minus 3x plus 2. We have to find out this. So for this what will we do? Actually here we are verifying, that's it. So this is the polynomial. So first of all we should suppose this polynomial as P of x. P means polynomial, x means variable. So in this polynomial, we have the variable x. That's why we are assuming it as p of x. That is equal to x square minus 3x plus 2. So what we are asked? We are asked to verify with 2 and 1. So I will write p of, in the place of x, write this 2 is equal to, x means 2, x has a square, so 2 has a square, minus 3x means 3 into x. 3 into x is 2 plus 2. Simplification. 2 square is 2 into 2, that is 4. Minus 3 into 2, 6 plus 2. By simplification, we got 4 minus 6 minus 2 plus 2, 0. Yes, by substituting 2, we got the answer 0. From this, what we can say? We can say that x is equal to, x is equal to 2 is the 0 of this polynomial. So is we have to find for 1 also. The previous problem what I said. So for that question, we have only 1 0 of the polynomial. For this question, two numbers are given, 2 and 1. So we are asked to check for two numbers, 2 and 1. So here observe the degree. This is x square, its degree is 2. So this is the highest degree. That's why this polynomial is called quadratic polynomial. So quadratic polynomial has the degree 2. That's why it has two zeros. So again we have to substitute 1. P of x is equal to x square minus 3x plus 2. This is the question. In this, write P of 1 is equal to 1 square minus 3 into 1 plus 2. So 1 minus 3 plus 2. 1 minus 3 minus 2 plus 2, 0. Yes. So x is equal to 1 is the 0 of the polynomial. So its degree is 2. That's why we got two zeros. Here what we did not find the roots. Sorry, we did not find the zeros. We are verifying, that's it. Already in the question itself, 2 and 1 are given as zeros. So we are checking whether they are zeros or not. If we get, by substituting these, we get 0. That's why only these are called zeros. So, and I have used the one word, that is root. So zeros and roots both are equal. Actually both gives the same meaning, but so the words root and zeros, when will we use those words? I will explain. The same question is, if the question is given as x square minus 3x plus 2 is equal to 0. In the question itself, it is given as x square minus 3x plus 2 is equal to 0. Then it becomes an equation. If it is the equation, then we call them as roots. So here the equation is not given, only polynomial. That means expression is given. That's why, so they have used the word zeros. So they both give the same meaning, right? Okay. Next we will discuss example 5. What is this example 5? If 3 is a 0 of the polynomial, if 3 is a 0 of the polynomial x square plus 2x, x square plus 2x minus a, find a. For this question also, no need to find the zeros. Why? Because in the question itself, it is given that 3 is the 0 of this polynomial. So we should suppose this as p of x. So p of x is equal to x square plus 2x minus a. Here, for this question, 3 is the 0. Then actually what we know about zeros? that 0 will be substituted in the place of x, we get the answer 0. Already we know that the meaning of zeros is that one only. So that what we have to do, we should write p of, in the place of x write 3 is equal to, in the place of x write 3 square plus 2 into 3 minus a. Here by substituting these 3, this total expression, total polynomial will be equated to 0, becomes 0, because 3 is a 0, he has given that. So that this, substituting this value, this definitely this value will become 0. That's why I am keeping is equal to 0. Next, simplification, 3 square 9 plus 6 minus a is equal to 0. So 9 plus 6, that is equal to 15, minus a is equal to 0. So here we should find the value of a. So always the variable, here the variable is a. So variable should not be negative. So if it is negative, then we should send it to another side. So this minus a should be sent to another side. It will become a, and 15 remains in the left hand side. So 15 is equal to a means we can write this as a is equal to 15. So if a is equal to b, then we can write it as b is equal to a. So this is symmetric property. And so like this we can complete exercise 2.2. In the 2.2 also, we have the first bit are same, find the value of the polynomials. So that we can do. The second bit, we should find the p of 0, p of 1 and p of 2. So you have to finish exercise 2.2. In this third bit is verify whether the values of x given in each case are the zeros of the polynomials or not. Here what we have to do, we have to substitute the values in the polynomial. If you get the 0, then that value will be the 0 of that polynomial. So if not, they are not the zeros. That's it. So like that you have to find. And in the fourth bit, find the 0 of the polynomial. Yes. So for this fourth bit, we will discuss. The fourth bit, in the fourth bit, we have to find out the zeros ourselves. So by trial and error method, we should not find. Directly we can find. So let me explain one. The fourth bit, fifth one I am explaining. That is f of x is equal to x square. So find the zeros. So what we have to do? Just write f of x is equal to x square. So make it is equal to 0. Why? So every expression, while finding the zeros, every expression of the polynomial definitely should be equated to 0. Then after that, we should find out the value of the variable. Here the variable is x. That's why x should be kept here itself. On the right, it is in the left hand side. So keep this in the left hand side. And we have to send this square to another side. When a square goes to the another side, it will become square root. So square root of 0. So x is equal to, the square root of 0 is 0. But before removing the root symbol, definitely there should be plus or minus symbol. So x is equal to, actually 0 is neither positive nor negative. So that it should not have any sign. That's why we have to write 0. So for this question, the zeros is f of x is equal to x square. For this question, the zeros is x is equal to 0. That's it. And the fifth question is, if 2 is a 0 of the polynomial, that means 2 is the 0 of the polynomial. We know that. So f of x is equal to 2x square minus 3x plus 7a. Find the value of a. So this question is same as example 5. And I will explain the sixth question. The sixth question is, if 0 comma 1 are the zeros of the polynomial, 0 and 1 are the zeros of the polynomial, Here we have two zeros. That means in the question the polynomial will be quadratic polynomial. So polynomial f of x is equal to 2x cube minus 3x square plus ax plus b. So here we don't know the values of a and b. So we should find out them. Find a comma b. So how to find that? So it's actually in the example file we have given only one root. But here we have two roots, that's it. So f of x is equal to 2x cube minus 3x square plus ax plus b. So first root is 0. Root means first zeros. F of 0 is equal to, in the place of x write 0. 2 into 0 cube minus 3x square means 3 into 0 square plus a into 0 plus b. Here by substituting this 0, this total polynomial will be equated to 0. So we should simplify. 2 into 0 cube is 0, 3 into 0 square is 0 into 0 0 plus a into 0 0 plus b is equal to 0, and 2 into 0 0 minus 3 into 0 0 plus 0 plus b is equal to 0. So total this value will be b equal to 0. Yes, we have found one value for b. So by substituting this b is equal to 0 in that polynomial, we get the polynomial is f of x is equal to 2x cube minus 3x square plus ax plus 0. So I am substituting b is equal to 0. Next, second root is also given. The second zeros is 1. So in this we substitute 1. So f of 1 is equal to, substitute in it. In the place of x write this one, and 3 into x means 1 plus a into 1 plus, no need to write this 0, but we write is equal to, by substituting this it will be 0. So 2 into 1 cube is 1 minus 3 into 1 square is 1 into 1 1 plus a into 1 is a plus 0 I won't write is equal to 0. So we will simplify that. 2 into 1 2 minus 3 into 1 3 plus a is equal to 0. Next, 2 into minus 3 minus 1 plus a is equal to 0. Here we have to find out the value of a. So a has the sign plus, that's why no need to send this a to another side. So what we have to do, keep a there itself and send the remaining terms to another side. So minus 1 goes to another side, it will become plus 1. Already we have 0, that's why no need to write that. So a is equal to 1. Yes, like this we have to find out. And this is exercise 2.2. So you have to finish the remaining questions. Thank you.